All right, recording screen roll. All right, so we're back to this. Right, so you guys could have figured that out, right? I mean, we've done so much trigonometry, right? Okay. So wouldn't it have to be the case that tension force times cosine of the angle is equal to the weight? That would have to be true, right? Right? Just from that, right? That would have to be true. So this minus this is equal to 0. It just leaves this set. Then how about the sum of the forces in the x direction? The sum of the forces in the x direction is equal to not 0, but what? Centripetal force. Yes, yes, because there's a net force on this ball, right here. And so this would be ft times sine theta, wouldn't it? Isn't this ft times sine theta right here? So the tension force times sine theta is equal to mv squared over r. True? Right. Now we need to put these ideas together. We got this equation, we got this equation. Do you think we could do a system of equations between those two system of equations? Right? You know what? I bet if there might be different ways to go about this, but you could do substitution. Could you divide these two equations? Is that okay? Because if you do, it looks like the tension wants to cancel out. If I do like this divided by this, here, I'll stack them right on top of each other. Ft sine theta equals mv squared over r. Just copy pasted that. Ft cosine theta is equal to mg, right? There's your system right there, right? Can I divide one equation by the other equation? The tension cancels, the mass of the ball cancels, right? Okay, and then so the geometry of this conical pendulum, right? Like once you get this ball going at some speed, whatever that speed is, now the tension might change depending on the mass, but you could change out the mass and it would need some speed to stay that exact circle with that radius above. Okay. Okay. So, guys, what is sine divided by cosine? Tangent. Tangent. Tangent of the angle. Okay. And then is this v squared divided by rg? Okay. So could that describe the motion for that conical pendulum right there? Okay. So whatever that angle, if that's a 29-degree angle, now you know something about the relationship among here. How fast is it going? What's the radial size of the circle? And what's the gravity field of the planet? Okay. Let's see what they came up with. They said g tan theta equals v squared over r. Oh yeah, you just take this g and cross multiply it. Same thing. Maybe they got there a different way, or right. So same thing, right? Yeah.
So you would isolate ft from the equation.
Yeah, you could do that too. Yeah, you could solve in terms of ft, solve in terms of ft. You could do like a substitution, and it would lead you to the same answer. Yeah, just be a few more steps, but you do that too. Yeah. Okay. Okay, and then last one. Right, well, we'll just look at last one because one possibility left. Okay. So we got a roller coaster at the bottom of a loop. Right? Now, if it's just sitting there at rest, then the weight and the normal force would be balanced. But if it's in motion, then which force is bigger, the weight down or the normal force up?
Normal force up.
It's got to be the normal force up. Because if you take the difference between those two, now you have a net force that's equal to the centripetal force that's holding it in that loop. Right? And okay, that's what they do here. The normal force up minus the weight down equals the centripetal force. Boom, boom. Okay. All right, so you guys get this? All right. Next thing. All right. All right, let's go switch my computer over here.